Hello everyone, welcome back to e-learning with Triveni. Now I am going to explain aromaticity or Huckel's rule. These are the contents I am going to explain now. Aromaticity, Huckel's rule, requirements for aromaticity, examples with structures, differences between aromatic, anti-aromatic, non-aromatic and biologically active heterocyclic compounds, and finally tricks to remember aromaticity. First of all, how we can decide whether the compound is aromatic or not? Can any guess? Yes. Based upon aromatic smell, only aromatic smell is sufficient to decide aromatic character? No. With some aromatic smell also, some compounds are coming under the category non-aromatic. Examples like esters. And when you see compounds possesses one or more benzene rings, can we say such compounds are aromatic? No. Without benzene ring also, some compounds possesses aromaticity. Examples like furan, thiophene, pyridine. Then how we can say whether the compound is aromatic or non-aromatic? Compounds which can satisfy the Huckel's rule are considered as aromatic compounds. What is Huckel's rule? Huckel's rule considered as 4n plus 2 is equal to pi electrons. This rule is helpful to identify the aromatic character or aromaticity for the compound. Huckel's rule refers to the number of pi electrons but not the number of atoms in a particular ring. According to the Huckel's rule, a compound is said to be aromatic if it satisfies the 4n plus 2 rule. Then requirements for the aromaticity. Here rule 1 is cyclic and planar, and here you can observe this benzene is cyclic structure, and when you see 1, 3, 5 hexa triene, and here we can found that there is no connection link between carbon atoms, so it is not aromatic. The rule 2 is compounds should follow sp2 hybridization, and when you see this structure of benzene undergoes sp2 hybridization and it has one vacant p orbital, it won't undergoes hybridization. So that is the reason benzene having sp2 hybridization. Rule 3 should have conjugated system. Now we can observe conjugated system means presence of alternative double bonds. Benzene having double bond and one single bond, again double bond and one single bond, again double bond and one single bond. This is conjugated system. If you take another example like 1,3 cyclohexadiene, here in this case the double bond is absent here. And when you see 1,3, 5 cycloheptatriene, here also the double bond is not present. So in this area double bond is not present. So that is the reason 1,3 cyclohexadiene and 1,3, 5 cycloheptatriene, they are not aromatic. So benzene is aromatic. Coming to the rule 4, an aromatic compound should follow 4n plus 2 pi electrons where n is equal to as an integer. Integer means it may be 0, 1, 2, 3 and so on. Then differences between aromatic, anti-aromatic and non-aromatic. Aromatic means till now we discussed it should have cyclic structure and planarity and completely conjugated system and should follow 4n plus 2 pi electrons. Examples like benzene, pyrrole, pyridine, tropylium cation, cyclopentadienyl anion. Coming to the anti-aromatic means it should be cyclic and also planar, completely conjugated, and here it is following 4n pi electrons. Remember, it is following 4n pi electrons instead of 4n plus 2. It is following 4n pi electrons. Examples cyclobutadiene, cyclopenta cyclopentadienyl cation. Here it is cation, in this case it is anion. And non-aromatic means a compound that lacks one or more of the four requirements. To be aromatic are considered as non-aromatic compounds. Examples: 1,3 cyclohexadiene, cyclooctatetrene, cyclopentadienyl radical. So, in this case it is radical. So, this is regarding differences between aromatic, anti-aromatic, non-aromatic. Now, let me explain by taking the examples. We will see the first structure, benzene. In the benzene, the pi electrons, how many pi electrons are there? Here 6 pi electrons are present. That means one double bond indicates 2 pi electrons. One double bond indicates 2 pi electrons. Totally how many pi bonds are there? 3 pi bonds, and that means it is having 6 pi electrons. It is having 6 pi electrons. And when you apply 4n plus 2 rule, here n is equal to 1. Why? Because benzene is having only one ring structure. That is the reason n is equal to 1. 4 is multiplied with 1. 4 1s are 4 plus 2 is equal to 6. So, here we got the value is 6. So, the value 6 pi electrons, and here also 6 pi electrons. The value is same. That is the reason benzene is aromatic. Next example, when you take naphthalene. Naphthalene, the bonds, pi bonds 1, 2, 3, 4, 5. Totally 5 pi bonds are there. 1 pi bond is equal to 2 pi electrons. That means total pi electrons here 10 pi electrons. When you apply 4n plus 2 rule, here 2 rings are present. So, that is the reason n is equal to 2, and here 4 is multiplied with 2. 4 2s are 8 plus 2, totally 10. So, the value 10 and 10 pi electrons. So, that is the reason naphthalene is aromatic. Next, coming to the anthracene, when you see the structure of anthracene, here totally 3, 4, 5, 6, 7 pi bonds are present, and that is nothing but 14 pi electrons when you apply 4n plus 2 rule, and here 3 rings are present. That is the reason I written n is equal to 3, that is 4 is multiplied with 3 plus 2, that is equal to 14. Anthracene also aromatic. And Huckel's rule also extended to explain the anions. One of the examples, cyclopentadienyl anion. When you see the structure of cyclopentadienyl anion, here when you see this anion means negative charge, that indicates presence of electrons. So, here instead of taking 2 double bonds, and we have to consider these electrons also. Why? Because these electrons or the bonded electrons, these are involved in the resonance, and because of the resonance it forms the resonance structures. That is the reason we have to consider number of pi electrons means 6 pi electrons. When you apply 4n plus 2 rule, here the value is 6 and pi electrons also 6. That is the reason. Now, can you say whether it is aromatic or non-aromatic? So, that is aromatic compound. The next one is cyclopentadienyl cation. When you see the structure, cation indicates plus charge, that means lack of electrons. So, here electrons are not present, there is no resonance. So, how many pi electrons are there? 4 pi electrons are there. When you apply 4n plus 2 rule, here 4 multiplied with 1 plus 2, totally 6 electrons, and pi electrons are only 4. And that is the reason it is anti-aromatic. What is anti-aromatic? It is cyclic, planar, sp2 hybridization and conjugated system, and it follows 4n rule. It contains 4n is equal to pi electrons. So, here 4n is equal to, that is 4, and pi electrons are also 4. That is the reason cyclopentadienyl cation is coming under the category of anti-aromatic. Another example, cyclopentadienyl radical. Radical means only a single electron is present. So here total number of electrons means we have to count as an F5 because of 2 pi bonds and 1 radical will be counted. 2 pi bonds means 4 pi electrons, 1 radical, 4 plus 1 is equal to 5. When you apply this rule, so it is the final value is 6 and the pi electrons number is 5. So it is non-aromatic. It is not at all following the Huckel's rule. That is the reason this is coming under the category non-aromatic. Does not contain 4n and also does not following 4n plus 2 rule pi electrons. Next example, tropylium cation. When you see the structure of tropylium cation, it is having positive charge. Positively charged carbocation is sp2 hybridized carbon and has a vacant p orbital. Because of presence of vacant p orbital, it is following 4n plus 2 rule and it is an aromatic. It is an example of aromatic. Next example, cyclobutadiene. When you see the structure of cyclobutadiene, and it is having 2 pi bonds, that means 4 pi electrons are 4. When you apply 4n plus 2 rule, totally it is having 6 pi electrons, but it is not obeying the Huckel's rule. That is the reason cyclobutadiene is coming under the category of anti-aromatic. It contains 4n is equal to pi electrons. Next example, cyclooctatetrene. Cyclooctatetrene. In this structure, we can observe 4 pi bonds are present. That means 8 pi electrons are there. When you apply 4n plus 2 rule, and we got the value is 6 and the pi electrons number is 8. So it is non-aromatic. It is not obeying 4n rule and also not obeying 4n plus 2 rule also. That is the reason cyclooctatetrene, even though it is cyclic structure, it is not aromatic. And Huckel extended his rule to heterocyclic compounds also. Examples like furan. In the furan, it is in a 5-membered heterocyclic ring which contains oxygen as a heteroatom, and oxygen has 2 lone pair of electrons. Among 2 lone pair of electrons, 1 pair of electrons, that is bonded electrons, they are involved in the resonance. Because of this region, we can count the pi electrons, means instead of 4, we have to count as an 6. When you apply 4n plus 2 rule, and we get the value is same, number of pi electrons, and when you apply 4n plus 2 rule, that is aromatic. When you take other heterocyclic nucleus, example indole. Indole having heterocyclic atom nitrogen, and nitrogen also having one lone pair of electrons. These electrons are also involved in the resonance. Because of this region, we can say total pi electrons means 10 pi electrons. When you apply the rule 4n plus 2 rule, here n is equal to 2, because of it is in a fused ring, 2 rings are present, so n is equal to 2, and the value we get, that is 10, and pi electrons number is also same. That is the reason indole is aromatic. We will take another example, pyridine. In case of pyridine, here also nitrogen is attached with one lone pair of electrons, but here this lone pair of electrons are present in a vacant p orbital as in a perpendicular manner. We can observe here these electrons are present perpendicularly, not to the parallel to the nitrogen atom. That is the reason this lone pair of electrons are not involved in the resonance. That is the reason we have to consider pi electrons means 6 pi electrons, and it is following 4n plus 2 rule. That is the reason pyridine is aromatic. When you take other example, pyrrole is in a 5-membered heterocyclic nucleus which also contains heteroatom, nitrogen, and in this case also nitrogen is having lone pair of electrons. These lone pair of electrons are involved in the resonance. That is the reason we have to count the pi electrons, means 6 pi electrons, and it is also example of aromatic compound. When you see biologically active heterocycles, example histamine, it is having imidazole basic nucleus which contains 2 nitrogen atoms in the structure, and here we can observe one nitrogen atom will behaves like in a pyridine and other nitrogen atom will behaves like as in a pyrrole. So here number of pi electrons means we have to write it is in a 6 pi electrons. When you apply 4n+2 rule, and we can say it is in a aromatic compound. So this nitrogen, it behaves like pyrrole, this nitrogen behaves like pyridine. And biologically active amine, and it is formed in many tissues, histamine. Histamine has an aromatic heterocycle with 2 nitrogen atoms, and one nitrogen atom behaves like pyridine and other nitrogen atom behaves like pyrrole. Once again fast recall with differences between aromatic, anti-aromatic, non-aromatic. Aromatic means follows 4 rules, cyclic, planar, completely conjugated, and should follow 4n+2 rule. Anti-aromatic means cyclic, planar, completely conjugated, and should follow 4n pi electrons, and any one of the thing will be not obeyed, then the compound is coming under the category non-aromatic. Just fast recall with the 4 rules with more examples. Benzene we know cyclic and it is aromatic. There is no connection between the carbon atoms. Here carbon atoms are not connected, there is no conjugation, so that is the reason it is not aromatic. And here heterocyclic nucleus pyrrole, it is aromatic. There is no connection, conjugation is not there, that is the reason it is an alicyclic, that means not aromatic. And tropylium ion aromatic, and ion, and there is no connection link here, connection link is not there, that is the reason it is not aromatic. And cyclohexene, this is also not aromatic. Tetrahydrofuran also not aromatic. And just you have to get one idea, should be clear, all cyclic molecules are not aromatic. One of the example, even though cyclooctatetrene, it is in a cyclic, even though, but it is not aromatic, it is not obeying the Huckel's rule, 4n+2 rule, that is the reason it is not aromatic. And when you see other examples like a pyrrole and substituted pyrroles, here it is aromatic compound, substituted pyrrole, it is not aromatic, it is not obeying the Huckel's rule. And these are the other structures which will exhibit the aromaticity, which are not exhibiting the aromaticity. So you can see more examples I given here, and here we can observe number of electrons, 6 pi electrons are present, means it will exhibit the aromaticity because of the presence of 6 pi electrons, we can say. And yes, till now we discussed many factors. Now we will get confusion how to remember all those things. So for easy remembrance I am going to give one trick. Number of pi electrons means compounds contain 2, 4, 6, 8, 10, 12, etc. so on. And whenever I am saying here based upon number of pi electrons, if it is even number 2, 6, like not even number 2, 6, 10, 14, 18, so on, they are aromatic. And if the number of electrons 4, 8, 12 likewise means they are not aromatic. If you take based upon number of electron pairs, it is clear, this point is very clear. Number of electron pairs, it may be odd number of electron pairs 1, 3, 5, 7, 9. It obeys the Huckel's rule. Even number of electron pairs means it won't obey the Huckel's rule. Remember, odd number of electron pairs are present, it obeys the Huckel's rule. Even number of electron pairs are present means it won't obey the Huckel's rule. Let me explain this concept with examples. Here, when you see this example, in this case we can observe it is having one pi bond, that means 2 electrons are present. So, it is aromatic. So, number of electron pairs only 1, and here in this case cyclobutadiene, it is having even number of electron pairs. Even number of electron pairs means it won't obey the Huckel's rule. That is the reason it is not aromatic. Again, odd number of electron pairs. So, here 1, 2, 3 pi bonds are there. So, here number of pi bonds, it is odd number. So, it is aromatic. Again, a cyclooctatetrene, it is having 8 pi electrons. So, that is the reason it is not aromatic. So, these are the examples. Thank you.